Hello everyone. So in this video we will be building trust in digital transaction, a deep dive into smart contract escrow system. So before diving it, we will understand what Rootstock is. So Rootstock is the first and most established Bitcoin sidechain, offering a groundbreaking layer 2 solution that combines Bitcoin unmatched proof of work security with Ethereum smart contract capabilities. As a fully open source and EVM compatible platform, Rootstock enables developers to build and deploy decentralized application while leveraging the strength and security of Bitcoin network. So let's now discuss some of the key features that really make Rootstock special. So first one is security. So it is secured by over 60% of Bitcoin's hashing power through merged mining. Second is compatibility. So it is fully compatible with Ethereum's development tools and smart contracts. Third, versatility. So as it supports the DeFi application, tokenization and identity management. Fourth one is interoperability. So it contains function as a bridge between Bitcoin and smart contract functionality. So now we will discuss like what are exactly escrow systems. So escrow system acts as a trusted intermediary that holds funds until contractual obligations are met. So like as in traditional finance, this role is often played by banks or specialized escrow companies. With blockchain technology, we can implement this as a trustless, transparent smart contract. So a blockchain based escrow system typically involves three parties. First one is buyer. So buyer is the person making a purchase or payment. Second one is seller. So the person providing goods or services is called as seller. Third one is arbiter, which is a trusted third party who can resolve disputes. So now we will see the basic flow work, how escrow works. So initially the buyer deposits the funds into the escrow contract. Then the seller delivers the product or service. Third one is like the both parties confirm the transaction is complete. And the fourth one is like funds are automatically released to the seller. So in between, if a dispute arises, the arbiter steps in to make a fair decision about where the funds should go. So now we will begin with building our escrow system. So first we will make an folder name as escrow, and we will open this folder with an ID. So here I will be using cursor as an ID. So first we need some of the packages. Also, if you don't have Node.js installed into your local, just navigate to the nodejs.org and you can simply download the Node.js from here. As I already have Node.js installed in my local, I will be skipping this process. Second, like you should have the npm package manager, git as your version control, and like MetaMask installed in your local. So if you don't have MetaMask into your local attached to your browser, so simply search metamask.io, and from here you can just simply download the MetaMask and set up your account on MetaMask. Now we will head up to the development environment. Also, like while developing and deploying the contract, we will be using a Rootstock testnet. Test RBTC in your account. Simply search for Rootstock faucet and enter your address. So by this you will get your test RBTC, which will be helped useful while deploying the contract. Also, you should have MetaMask testnet, Rootstock testnet added to your account. So you can simply search for Rootstock testnet, or you can simply search for chain list, and into chain list you can search for Rootstock, and you should always check mark the include testnet button, and simply you should connect to your wallet. So it will automatically add a Rootstock testnet as your network on your MetaMask. So now we will proceed to our development journey. So first I will be making a folder directory. Let's name it as escrow contract. So as you can see, our folder directory has been created. Now we will navigate to the directory. Now we will initialize a new npm project using the command npm init-y. So it has successfully created the package.json. Now we will install the required packages. So the first one is hard hat. So we will simply install it using the command npm install save dev hardet, and as it is of from the nomic foundation, we simply add the nomic foundation. Then also we will be needing the hardet ethers, and finally we will be needing the .env, where we will be utilizing the env file into our development files. So yeah, our all the required packages are getting installed. So now we will be simply initializing the hardet. So until it gets installed, we can simply initialize the parallelly. So the command for the same is npx hardet init. So as we can see, our packages are getting installed, the node modules folder has been created. Now you can see all the required packages has been successfully installed, and all the dependencies have been gotten added to the package.json. Now we will be simply initializing the hardet using the command npx hardet init. So like for here we need to select the javascript project. We will keep the root directory as the same, and also we will add the gitignore file. Yes, now all the required files for the hardet has been successfully added to our main escrow contract directory. So contract is the folder where we are going to write our contract. Node modules, here is the folder where we add all our packages, dependencies needed for our project to run successfully. In test, we add the test cases for the contract. In gitignore is mostly used in the production level, where we add all our files that we don't want to push on the GitHub workspace. So hardet.config.js is the file where we write our configuration, and readme.md is the file we required when we add our code to the GitHub, where we write all the description of our project and steps to run it into your local. So now we will be creating a folder name escrow. Now we will be starting with writing our escrow sol contract. So first we will be adding the license, which would be MIT license. For that we will be adding the comment as spdx license identifier :MIT. Then we will be adding solidity with version as greater than 0.8.7. Now we will be writing a contract called escrow with few of the const as buyer, seller and arbitrum. So we will make the data type as address, and we will make it public. Now we will simply copy pasting this and add the remaining two one, and the third one is like arbiter. Now here we wrote the main three participants for our contract. Now we will add the amount and approval state. So we will define the data type as int uint256. We will also make it as public, and will define the constant as amount. Now we will write the variable as buyer approval with data type as bool, and we will also make it as public. Similarly, we will be writing the seller approval. Now we will be defining the possible states for our escrow contracts. So we will make its data type as enum, and we'll write few of the variable as awaiting payment, awaiting delivery, complete, and the last one will be disputed, and we'll make this variable as public, and we'll make it as a state. Now we will be writing few of the events for off-chain tracking. So there will be almost 5 events. The first one would be the deposited one, and we'll pass the parameters as indexed buyer, addressed indexed buyer, and the second one would be uint256 amount. The second one would be the event as delivery approved with data type as addressed indexed, and the name of the constant would be the approver, the one who approves. The third event would be the disputed with parameters as address indexed disputer. The fourth event would be the resolved, addressed indexed arbiter, and the second one parameter would be the release to seller. The fifth event would be the completed one with parameters as amount and recipient. So now let's break down what we just wrote now. So we declared a contract escrow, then we defined few of the state variable to store the address of all participants, then we create the variable to track the payment amount and approval state, then we define the enum for different state of the escrow, and finally we add the events to make tracking the contract activity easier. Now we will be adding the access control, like security is the paramount in smart contracts, so we will be adding it using the modifiers to control who can do what. So the first modifier would be the only buyer, and here we will be writing the condition as message.sender should equal to the buyer, and if it success fails, only the buyer can call this function. Similarly, we will be writing few of other modifiers. So the next modifier would be the only seller. So here we simply modified the only buyer modifier and make changes according to the seller modifier. Similarly, we have to write it for the arbiter. So we will simply name the modifier as only arbiter, and here we will be writing only the arbiter can call this function. Now we will define the modifier for the state, like in state, and here we will passing escrow state, and here we will simply writing the condition as, we'll simply copy it and will modify it according to the in state modifier. Invalid, here we can write invalid state for the action. So now we have successfully written all the required modifiers which act like security guards, ensuring all the authorized user can perform specific actions and that operation happen in the contract state. So now we will be implementing the constructor. So let's write the constructor with parameters as address with buyer, address of seller, and address of arbiter, address of seller and address of arbiter. So inside the constructor we will be writing the required conditions. So the first would be like the value of buyer should not equal to the address of 0, which one is the our address. Similarly, it should be there for seller and address arbiter as well. So we will be simply copy pasting it and we'll update it. So here it would be seller and here it would be arbiter, and if everything we will write address cannot be 0. And similarly we can also need to check like all the addresses of buyer, seller and arbiter should not be equal. So for that we will simply write the condition as buyer address should not be equal to of seller. Similarly, the buyer address should not equal to the arbiter and the seller address should not equal to the arbiter one. And if everything goes, then participants must use different addresses. We can split participants must be different addresses, and then we will initialize the values for the buyer, seller and arbiter. Buyer, seller and the arbiter, and the state would be escrow state dot awaiting payment. So basically this constructor takes the addresses of the buyer, seller and arbiter as parameters, then validate these addresses to ensure they are not 0 addresses and are all different, and then initialize the contract state to the awaiting payment. Now we will be writing the main escrow functions. So the first one would be the deposit function, and it would be of external payable and will be of validating the only buyer modifier with in state as escrow state dot awaiting payment, and into which we will be writing the require statement with message value greater than 0 and message as deposit amount should and amount should equal to message dot value, and state should also equal to the escrow state dot awaiting payment. Now we will be emitting the deposited function with buyer and message dot value, and here we will be passing the parameters as escrow state dot awaiting delivery, and inside which we will be initializing the value of buyer approval as true, and will emit the delivery approved with parameter as buyer, and then finally we will be finalizing. Now we will be writing the function for confirming the delivery. So let's name it as confirm delivery. Let's keep it as external and use the modifier of only seller with instead and passing the parameters as awaiting delivery from the escrow state. And here we will be setting the value of seller approval equal to true, and will be emitting the delivery approved with the parameter of value seller. And finally we will be writing the finalize function. Let's name it as finalize with, and we'll be writing the condition as if buyer approval and seller approval. Then call the payable with seller and transfer the amount, and we'll update the state equal to escrow state dot complete, and with emit the completed function with parameter as amount and seller. So basically this function deposit allows the buyer to deposit funds, changing the state to awaiting delivery. Then this approve delivery function allows the buyer to approve the transaction. Confirm delivery function allows the seller to confirm the delivery. Finalize. So this finalize an internal function that releases the funds if both parties approve. So now we will be writing the function for dispute handling, which is also like dispute resolution. So let's write the function for the same. So here let's name the function as dispute. Let's keep it as external, and then here we will be making the required condition. Let's simply copy it from the only seller and make the required changes. Required.sender should equal to send seller or required.seller, and here we will be giving the or condition, and here we will be setting message.sender equal to buyer, and only buyer and seller can dispute. And the second required condition would be the state should equal to the escrow state awaiting delivery, and the message would be can only dispute while awaiting delivery. And finally we will be updating the state value to escrow state dot disputed, and will emit the disputed with message.sender. Now similarly we will be writing the function to resolve the dispute. So let's name this function as a resolve dispute and pass parameter as release to seller, and let's make it as external with only arbiter, and in state with escrow state dot disputed, and if a release to seller then make payable with seller and transfer the amount. And if the if condition fails, then we will be simply payable the buyer with the transfer amount. And finally we will be updating the value of state with escrow state dot complete, and we'll call emitting the resolved function with arbiter and release to seller. So this dispute function allows either buyer or seller to flag a transaction as disputed, and the resolve to dispute allows the arbiter to decide where the fund should go. Now we will be writing the emergency functions. So let's name this function as refund buyer. Let's also make it as external with modifier as only buyer with instate, passing the parameters as escrow state dot awaiting delivery. So here we will be writing payable buyer with transfer amount, and will update the state of the escrow state of complete, and finally we will be emitting the completed one with parameter as amount and buyer. And finally we will be writing the function get balance. Let's keep it as external, which just returns, and value should be uint 256, which returns the addresses balances with data type address. So this refund buyer function is an emergency function allowing the buyer to get a refund. In real world scenario you will get add a time lock, and the get balance is an helper function to check the contract balance. So this is our complete escrow contract. So now we will be writing the test file for the contract. So let's write it into the test folder. So we will be simply making a new file called as escrow test. Here first we will be defining the const expect, and we will be using the library chai. The second one would be the ethers from hard at. Now we will be describing it with function let escrow, let name it as let small escrow. Then we will defining the variable for the buyer, seller, arbit and the other account. Now we will be defining a variable as deposited amount, which one will be like from ethers.utils dot parse ether with param as well. So now we will be writing the before each for the same, into which we will be writing the function. So let's write the before each with a sync function into it. Let's not write any name for the function, into which we will be describing the const as buyer, seller, arbiter and the other account, and we'll await until we get the signature, and the function would be the get signers. Now we will be deploying the contract, so we will define the escrow equal to await, and we will be using the get contract factory with parameter as escrow. Then escrow equal to await escrow dot deploy buyer dot address, seller dot address, and finally the arbiter dot address. And finally we will be awaiting the escrow dot deployed. Now we will be describing for the deployment one, so we will writing the display for the same. Describe for deployment will be passing the function, and into which we will be writing should set the right participants, and we will define the async function, into which we will be expecting await with escrow buyer, which should be equal to the buyer address, and the second would be for the seller, and third one would be the for the arbiter. So we will be simply copy pasting and make this required changes. Here it would be seller and here it would be for arbiter. Now we will be writing it for it, into which we will be writing should start in awaiting payment state, and we'll be writing the async function. Also we will be awaiting the escrow contract to connect the buyer and deposit the value of deposited amount. Next we simply expect the await escrow amount, which should be equal to the deposited amount. Now we expect the await with escrow straight, which should also equal to 1. Now also we will be writing it for which should not allow non-buyer to deposit and should process the transaction with both approves. Process the transaction when both approve, and here we will be passing the function with await escrow connect with buyer, and then also similarly deposited the deposited amount. So simply we'll copy paste it over from here. Now we will be initialize the seller balance with const. Let's name this variable as initial seller balance, which will be calling the get balance function. Now we will be approving both of the function using await escrow dot connect with buyer and approve delivery, and similarly for the seller with confirm delivery. Now we will be checking the results for the above function conditions. So we will be simply checking if its value is equal to 2, which is like the value of complete equal to 2. Then we will check the if the seller receives the funds or not. So for the same we will be defining a variable called const with final balance, final seller balance with amount await, calling the seller with get balance function. Now we expect the final seller balance dot sub and initial seller balance to be close to deposit amount, and ethers dot utils dot parse ether equal to 0.01, which allows for the gas cost. Now we will be writing it to handle the disputes correctly. So let's write it as should handle the disputes correctly async function. Here we simply connect, writing await escrow dot connect, passing the buyer address into it, and then deposit the value deposited. So simply we will be copying and just adding into it. Then we create the dispute. So for that we will simply writing escrow dot connect buyer and then dispute, and here we expect the await of escrow dot to equal to 3. Now we will getting the initial balance by writing the constant as initial buyer balance with await buyer get balance function. And now we will be writing the arbiter to resolve in favor of buyer. So simply writing await escrow dot connect arbiter to resolve dispute as false. And finally we will be checking the results with expect as await then escrow dot which should equal to the value to. Now we check the buyer if the buyer received the fund or not, writing the constant as final buyer balance with await buyer dot get balance. So it will eventually fetch the final balance of the buyer balance. So simply we will be writing check initial buyer balance which should be close to deposit amount. So we should write like 2 dot be close to deposit amount. And here we will be writing ethers dot utils dot parse ether which allows for the gas cost close to. So here we have successfully written the escrow tests. So now let's test the contract by npx hard hat test. So yes, as you can see our all the conditions test has been passed successfully. So just now create an env file where we will be writing the private key and RSK test URL. So you can simply get it on Rootstock website, and private key you can get it from your MetaMask. Now let's update the hardhat config. So here we simply given the version for the solidity, and we simply imported the test URL and the private key. So now let's create the deployment script. So now we will be creating a folder called as scripts into the escrow folder, and into which we will be creating a file called as deploy. Here we will be writing a async function naming main and will not pass any parameters. Now we will be defining a const with deployer and will now await ethers dot get signer. Now we will be simply logging. So simply writing console dot deploying contract with the account, and we will be simply entering the deployer address. Similarly for the balance we will be writing console dot count balance await deployer dot get balance with to string. Now we need to define the constant for buyer address, seller address and arbiter address. So simply you need to replace here with the address, actual address. So you can simply copy it from MetaMask. Similarly you can define the const for the seller address and for the arbiter. You simply need to update the address over here. So we can simply let's change over here for now. Now we need to define the const for escrow, which will be calling the function of get contract factory parameter as escrow. Now we will be defining the const for the small escrow variable constant escrow dot deploy parameter as buyer address, seller address and the arbiter address. Now we will wait for the deployment, and finally we will be simply logging as console dot and writing escrow contract deployed to, and the address is escrow contract, and we'll be displaying the address escrow dot address. Now we will be simply writing calling the main function. So main which should exit the process by doing exit process dot exit with 0 value into it, and then we will be simply catching it and logging the error as console dot or by doing console dot error and displaying the error into it, and then finally process dot exit. So here we simply wrote the deployment script for our contract. So this would be our final code base structure. Now we will be simply deploying our contract by writing the command. So the command for the same is npx hard hat run script slash deploy dot js, and we'll be setting the network as rsk testnet. So now it's deploying our contract address contract. So as we can see the account balance is displaying and the addresses for, so now it's deploying our contract to the Rootstock testnet. So now you can see our contract has been successfully deployed. If you face any kind of doubts, you can simply navigate to the Rootstock website and join their Discord channel and ask your doubt under the respective channel. Also, you can ask to the Rootstock AI chatbot, which can easily solve your doubts in real time. So that's all. Thank you, everyone.